Hey guys, this is the first part of the video on algebraic properties. There are a number of different properties. This video is going to focus on all of them. The next video is going to be on distributive properties. So for the worksheets and whatever class activities we do, we're going to focus on these properties for tonight, and then the next one's going to be on the distributive property. If you feel advantageous and would like to go ahead and watch the other videos, go for it. There's another one on distributing property that's going to be posted probably a little later this afternoon. So this is on algebraic properties. There are three main properties. There are identities, commutative, and associative. And each has their own little thing. Identity is actually, I think, one of the neatest ones because we've been using it actually all throughout the past few chapters of solving equations. The identity of adding, the identity means if I add this particular number to anything, it doesn't change. What number do I add to anything that doesn't change? If I don't give you any money, you don't have any more money, and you haven't lost any. And if I don't take any money, you haven't lost any money either. So the idea of addition, well, for addition, a plus 0 is a. A does not change. That's the additive identity of, 0. Multiplying, think about it. What number do you multiply by that doesn't change a number? 1 times anything is, 1 times a million is a million. So B and A are any number, any real number. So B times 1 is still B. So those are the identities. Really useful. We've been using them in our, look how I solve the equations. I always circle when there's adding the opposite. I always put a 1 when we divide or multiply because those are the identities of addition and multiplication. Huge. Okay, let's go on up. Next is commutative. Think about it. When you go home, the way you get home is the same way you come here. Bless me. The way you go somewhere is the same way you come back. It's just in opposite order. If I give you $5 and then I give you $2, that's the same if I give you the $2 and then the $5 later. If I change the order, it's okay. So for adding, that's fine. That's the commutative property of addition. N plus x is equal to x plus 5. And multiplication, it's the same thing. I can multiply in any order if that's all I'm doing. 2 times 3 is 6. 3 times 2 is 6. 2 and 3, flip them around. So those are commutative properties. They let me rearrange things. Associative property of addition means I don't necessarily have to add the first 2 numbers I see. Like if I see 2 plus 4 plus 8, I don't have to add these together first, per se, to get 14. I could, for instance, add 4 and 8 together to get 12, and then that makes 14. So, that's an example of associative property. Same thing with multiplying. So the idea is, I don't have to multiply A and B first, or add A and B first. I can add B and C first, and then add A. You can only do this if all there is, I'm tired all of a sudden. You can only do this if all there is addition signs. Multiplying, same thing. Now, I've only shown properties of addition and multiplication because, this is why I show this, subtraction is a fancy way of adding the opposite. That's why I always change a minus to a plus and add that negative, so I can use these properties, especially commutative property, because that's huge. That's why I change every minus to a plus. So I'm going to be doing that on a more regular basis because of this property, but because it's not a subtraction. 2 minus 3 is equal to -1, which is definitely not the same as 3 minus 2. That's why those are different. That's not commutative property of subtraction. That doesn't work. These aren't equal. So to think about. Okay, well those are basically the definitions. Let's look at a couple examples and we're basically done. Number one, example number one, simplify an expression using GEMDAS. Then use commutative or associative properties and simplify it another way. So we're going to do it normal, and then we're going to play with the numbers a little bit. So here we go. Pencil works. 15 minus 19 plus 16 plus 19. So let's just do it plain out. 15 minus 19 is negative 4 plus 16 plus 19, right? Negative 4 and 16 make positive 12 plus 19. 2 plus 1 is 11. 11 plus 1, 2. Sorry, I carried a 1. 1 plus 1 is 3. So this is equal to 31. Okay. Sorry, just now starting me on. So that's just flat out using order of operations. Get it done. Take a minute and think about what you're seeing up here. I'm going to rewrite this. We're looking for little tricks. I'm going to take a second to rewrite this with a plus negative 19. And take a moment and think about it. What do you notice about all the numbers up there? Only one's negative. And hey, it's negative 19. Here's positive 19. If we add the opposite, what do you get? 0. We've been adding the opposite almost the entire year so far. So I'm going to use commutative. Commutative, that means commutative property of addition, COA. So I'm going to put 15 plus 16 up here. So I'm switching these two. Plus negative 19 plus 19 equals, well, now I'm going to use commutative property of, or sorry, associative property of addition. Hey look, these equal 0. They're gone. This, I'm even going to show it like this. I know negative 19 plus positive 19 is 0. What's left? 15 plus 16. That's it. 5 plus 6 is 1, carried 11, carried 1. 1 plus 1 is 3, 31 again. Look how easy, I don't have to deal with 1, 2, 3 steps of like adding a negative and then adding the, no. Negative 19 and 19 cancel each other out. Deal with everything else. Great, great tool. Ugh. Man, I don't know what's going on. Maybe I should drink a cup of coffee before I do this. 17, 5 times 17 times 2. Again, we're just going to flat out do it out. 5 times 17. 5 times 7 is 5, 35. 5 times 10 is 50. 5, 3, 5. This is 50. So this is 85 right here. And if you look, now we got 85 times 2. Right? Gotta do that. 85 times 2. 2 times 5 is 10. 2 times 8 is 16 plus 1, 17. So this is 170. Take a moment, just think about it. If I could somehow make a number that just moves decimals, that would be a lot easier. Make numbers that move decimals. This has been the whole last week. What number lets you move decimals? 10, 100, 1,000. If I can make those numbers, it makes life so much easier. And sure enough, 15 just 5. If I move these two, sorry, not those two, I'll move to 17 and 2. So I have 5 times 2 times 17. 5 times 2 is 10 times 17 10 just adds a 0. It's 170. It changes the order of magnitude. 170. 31. So what did I use again? I used commutative property of multiplication. CLM. Really neat, right? It lets me switch numbers. Makes it a little easier. I don't have to do any long division. I know what 5 times 2 is. 10 times some number, move decimal. Done. Let's think about this one. C. Let me zoom all of it. I'm just going to flat out do it using order of operations. 6 and negative 8 make negative 2. Plus 19 plus negative 11, put that in parentheses, plus 13 plus negative 5. And I use parentheses to clean it up to make it look a little easier to read. Negative 2 plus 19 is 17, plus negative 11, plus 13, plus negative 5. 17 plus negative 11 is positive 6, or yeah, 6, plus 13 plus negative 5. 6 plus 13 is 19. And 19 plus negative 5 is 14. I keep adding and subtracting and adding and subtracting. What a headache. A lot of work, right? Here's a neat trick of commutative property. If I've got a bunch of negatives and positives that I'm adding together, I can actually move them around. And this is a really cool trick. I can put, I can actually put all the positives in the front and all the negatives in the back. Let's do that. 6 plus 19 plus 13. All my positives in the front. Plus negative 8 plus negative 11 plus negative 5. A positive plus a positive is a positive. You just add them together. Negatives build together to make a big number. Super fun. Let's do it. I'm going to take 8 and negative 11 because if you haven't noticed, take a moment to think about it. 8 plus negative 11 makes negative 19 plus negative 5. 19? Do you see that? Negative 19? Look, I got a positive 19. Let's do what we did in example A. I'm going to put 19 right here. I'm just going to switch 19 and 13. This right here, hey look, that's 0. Sick, do it. 6 plus 13 is 19, plus negative 5. I'm adding those positives together. Now I only have to subtract once. 19, I owe someone $5. Well, here's your $5. I still got $14 left. But look what the law, look, I got to cancel two things out. If you notice something, go with it. If you think, hey, why don't I just do this little, like, these laws allow for so much freedom in math. They give you a chance to really do something your own way. And that's what I really like. Last few examples. This is going to be quick. This is actually going to be a test this is basically a test you're going to be taking. Heck, I might even use these same examples. Might want to think about that. Maybe, maybe not. We'll see. Name the property used. I'm just saying name the property. 14 plus 19 plus 6 is equal to 14 plus 6 plus 19. Well, I switched 19 with 6. If I'm rearranging something, if I'm commuting, I'm moving stuff around. Commutative property. Commutative of nothing but a bunch of plus signs, so it's got to be addition. Commutative of addition. Commutative property of addition. But I'm okay with COA. B. Nothing but a bunch of multiplying. So think about that. There's always two parts. There's something of something else. So it's either identity, commutative, or associative, and then addition or multiplication. It's never subtraction, never dividing. So that's how I think about it. You got 3 options for the first word, 2 options for the other one. 10 times 1/3 times 36. Or I can move those parentheses. 10 times the product of 1/3 and 36. Check it out, dudes. Isn't this the coolest? Look. Here's 10, here's 10. Here's 1/3, here's 1/3. Here's 36, here's 36. The order didn't change, so it's not commutative. I don't see 1 or 0, so it's not identity. It's got to be associative. Of nothing but multiplying, so it's got to be multiplying. Multiplication. Okay? Why would you do that, Mr. V? Because think about it. 1/3 really means just divide by 3. That's not going to give me a whole number. That'll give me 12. That's a good reason right there. I hate fractions. Multiply by 36. Easier than 10. Gotta think about it. C. 4 times 28 times 25. And this is again, colored pencils are great, I think. Here's 4. Here's 38. It's the second number, but it's the third number. Uh-oh, their order is changing. If the order changes, that must be commutative of, I only see multiplying. Thus, it must be multiplication. Such a great tool. 4 times 24 is 100. 100 means I'm adding zeros or taking away. That's why I would use it. Such a great tool. I love it. It makes stuff so easy. 1 times some huge number, 1,238,614 is equal to 1,238 times 6. If it doesn't change and a number vanishes, that's identity. Of, it's multiplying, so identity of multiplication. I kid you not, this will be a standards test. I kid you not, it will be, because I love it. It's so straightforward. That's algebraic properties. It's just playing with numbers, having some fun. It's great times. I love it. Have a great day. See you guys next time.